Alright guys, today we're going to go over solving equations. So this is an Algebra 1 concept, so hopefully it's all review, but even if you haven't seen it before, we're going to kind of go over it. Now, solving equations is basically what everybody thinks of algebra, where you're trying to find the letter. You want to know what number you could put in there, right? For x, that's going to make this a true statement, right? The way to do it is you're going to get x by itself. So x by itself. Now, the best way to do that is going to be PEMDAS in reverse. That's pretty much going to make your life a little bit easier. So here's usually what I do. So this is just what I do. So I usually write it out like, vertically, because that's normally what we do. And when I want to solve, I'm going to work up. If I told you to simplify, you'd go from the top down to the bottom. You'd get rid of side parentheses. So it's just kind of working backwards, right? Now, addition and subtraction, they undo each other, so I always put a double arrow there. So I use this a lot. This is good for one variable. So if you have one type of letter, right? M and D, multiplication, division, they undo each other. So if you have multiplication, you use division to get rid of it, and vice versa. Exponent, we're not going to get there right away, but we usually use a radical, and then this plus or minus symbol will come up, right? And it's really kind of, the only way you can kind of get rid of parentheses is if they just kind of go away on their own. So if you see addition, use subtraction to get rid of it. If you see subtraction, use addition to get rid of it. If you see multiplication, you divide on both sides. And if you see division, you multiply on both sides. So the other thing we got to remember is that we have to whatever we do on one side, do the same thing on both sides of the equation. So we want to keep what I wanted. We want to keep things balanced. And that's just basically going to mean whatever you do to one side, same on both sides. That's called the property of equality. So it says basically if you have an equation, whatever you do on one side, you have to do the other. So for this one, I have 3 times x equals 39. So I look up here, right? And I see that all I have is 3 times x, which is multiplication. So I check my arrow, how to get multiplication and divide. So that means I'm just going to divide by 3 on both sides. 3 divided by 3 is 1. So you want to make the number go to 1 if it's with the x, or 0 if it's added or subtracting. So 1 because then I have x left. 39 divided by 3 is 13. So that's my answer. Now anytime you have an equation, you can always check your work. So 3 times 13, this is me just plugging it back in. Does this equal 39? It does. Right? So that's how you check your work. Alright, so the next one we're going to work on is we want to first make sure that we have one variable. Because if we have one variable, right, then I can use PEMDAS backwards because it's a solve problem. Alright, solve. Alright, one variable. So I see an equal sign that tells me right away it's likely a solve problem. I see just the x. So that means there is one variable. That means I'm allowed to use PEMDAS backwards. So now I go through and I always start at the bottom. Do I see any subtraction? I see subtraction right here. So to get rid of subtraction, I have to use addition. That's why I add 4 to both sides. The reason I add 4 to both sides is called the addition property of equality. So if you add 4 to one side, you have to do the same to the other side to keep things balanced. Minus 4 plus 4, they cancel out. So now I'm left with 1/2 x equals 9. Right? So Now I'm going to go through, I'm going to look and see what I have left in my... So there is no more subtraction. So I took care of the subtraction. I don't see any addition. You could look at the fraction as division, but I'm going to look at it for multiplication right now, just going to make everybody's life a little bit easier. Because I'm going to say it's 1/2 times x. So how do I get rid of multiplication? Well, to get rid of multiplication, I have to divide. So to get rid of that, I'm going to divide by 1/2. That's not bad if you have a calculator. You can always also just multiply both sides by 2. That's another way to get rid of fractions. So I multiply both sides by 2, or I divide both sides by 1/2. I end up with x equals 18. Now remember, anytime we solve, we can always check our work. So I'm just going to put 18. I'm going to plug it in right there. So I'm going to say 1/2 times 18 minus 4. What does that equal? Well, half of 18 is 9. 9 times 4 is 5. It equals 5, just like I wanted to. So I know this one is correct. That's it. Alright, so I'm going to do the exact same thing that I've been doing once again. So I'm going to start off with, I'm going to look at the bottom. Okay, do I see any subtraction in this problem? I do not see any subtraction. Alright, now I see addition. How do I get, I see plus 7. Alright, how do I get rid of addition? I have to subtract 7 from both sides. Right? Remember, that's a subtraction property equality. When you were doing equations, if you do it to one side, you have to do the other. Like sometimes in grade school, they might have had you put that line in there. It doesn't matter if you did that or didn't do it. I don't really. It's personal preference. If you want to put it there, put it there. So the 7's cancel out on the left side, so I have 2x equals minus 21 minus 7 is minus 28. Think about it. If you owe your dad $21 and you borrow 7 more, you owe him $28. All right. So now there is no longer any addition. I don't see any division. I see multiplication. That's 2 times x. How do I get rid of multiplication? I divide. So now I'm left with x equals negative 14. I'm done. Once x by itself, you're done. If you want to check your work, you say 2 times negative 14 plus 7. Does that equal negative 21? Well, 2 times negative 14. So this is a question mark. I don't know if this is true. This is me checking my work. 2 times negative 14 is negative 28, plus 7 is negative 21. That's what I want. Alright, so it's right. I'm done. Alright, next one is a very similar problem. So if you haven't figured out, these are all the problems that were on that Kahoot. That Kahoot was a pretest. So I'm just kind of going over those and explaining and teaching how to do it if you didn't know how to do it. So I look at this one. Alright, I don't see any subtraction. I see addition, but that addition is actually inside the parentheses. So I can't get rid of the 3. The multiplication inside the parentheses. So I have to make the parentheses go away first. There's 2 ways to make the parentheses go away. I could use the distributive property. That's called the distributive property. So I call that like pizza delivery guy, right? 7's got to deliver pizza to 3 house and 4x's house, right? You could do that. So if I do that, I end up with 21 plus 28x equals 77. Or I could, that 7 is being multiplied by the parentheses. I could divide both sides by 7. I could divide both sides by 7. And I would end up with 3 plus 4x equals 11. Both of these are fine. It doesn't matter which one you like better. So if I do the left side where I distributed, I minus 21 from both sides. This is where a lot of people mess up in general, because they think that it's plus 28x, so they try to subtract 28. 28 is multiplying by x. So really, remember, addition can be rewritten. So this could easily be rewritten as 28x plus 21. And some people will do that. They'll always write the x first because it makes it easier for them to see the addition. So it has addition. So now, how do I get rid of addition? By subtraction. So I minus 21 from both sides. Alright, so now I have 28x equals 56. So the addition's gone. Now, I don't have any division. I have multiplication. So I have to divide everything by 28. So the red writing is the math that is coming from the problem. I made that math up out of thin air. If I make that math up, I got to do it to both sides. That's what keeps it equal. So I have x equals 2. Now I'm just going to check my work, right? I'm going to plug it back to the original. 7, 3 plus 4. Instead of x, I put 2 equals 77. So 4 times 2 is 8. 8 plus 3 is 11. So I get 7 times 11. Does it equal 77? It does. Now look, I'm going to do the green writing. Right? There's I'm going to minus 3 from both sides. Even though I'm not, remember, plus 4x, 4 is multiplying by x. It's what's going on with x. So even though I say plus 4, that is not addition, right? It's actually multiplication. The 3 is being added. So I have 4x equals 8. Now I can divide both sides by 4 because that's how I get rid of the number in front of the x. So I end up with x equals 2, just like we already found out. So look, it didn't matter which way we did it. They took us to the same spot. So pretty simple. So this one's a little bit more difficult because there's a bunch of parentheses going on. And right away, remember, I need one variable. I have x's here. I have an x here. I have an x here. So really, you don't use parentheses backwards until you get all the x's on the same side. So the first thing I'm going to do is I'm going to make all the parentheses go away. So I want to use the distributive property first. So I'm going to use the distributive property. That will make parentheses go away. Because remember, I want to get all the x's on the same side. So I'm going to take, so the distributive property says, I'm going to take 4, I'm going to distribute it to the negative 3x and the 1. So I call it pizza delivery guy. So 4s deliver pizza to negative 3x's house. He gets minus 12x. Now, pizza delivery guy, if he skips one's house, he's probably going to get in trouble. So he's got to go to both of them. That's how it works. Negative 10. His route is x and minus 4, not negative 14x because it's not part of it's not part of the parentheses. So negative 10 has to go to x, and negative 10 has to go to negative 4. So I get negative 10 times x is minus 10x. Negative 10 times negative 4 is plus 40 minus 14x. So I have x's here, here, and here. So I want all variables on one side. So the first thing I'm going to do is I'm going to combine like terms. So I'm going to put the x's together. Now look, I have an x on this side, I have an x on this side. It does not matter if you move the minus 12 from the left side to the right side, or if you move. Alright, it's a perfect time to add our keyword. So that keyword is lightning. That's my dog's name. Keyword is lightning. So back to our problem. I always move the smaller of the two. So negative 24 is smaller than negative 12. So I'm going to add 24x to the right side because that will make it go away. And if I do it to the right side, so the red writing is on the right, it's not on the left until I write it there. I like to line it up. I'll keep my like terms. So this turns into positive 12x plus 4 equals 40. Now after all this work, now I can use my parentheses backwards. So I don't see any subtraction, I see addition. That's why minus 4 from both sides. So I get 12x equals 36. Now I got to get rid of the multiplication, so I divide by 12 on both sides. So I end up with x equals 3. Now look, I'm going to put 3 in here. I'm going to put 3 in here. I'm going to put 3 in here. This is a good way to review simplification, right? So, it reviews a bunch of different things here, all right? Or evaluating. You'll see the word evaluate means when you plug and chug. Negative 3 times 3 is negative 9. Negative 9 plus 1 is negative 8. 4 times negative 8 is negative 32. So the left side is negative 32. 3 minus 4 is negative 1. So I get negative 1 times negative 10 is positive 10. And then negative 14 times 3 is minus 42. So negative 32 does equal negative 32. It works. We know we did it right. So this is a correct answer. Alright, this one very, very similar. Once again, I cannot use parentheses backwards right away because I have two different letters. Now the biggest thing that people hate is fractions. So the easiest way to get rid of fractions is just to multiply both sides by the denominator. So I'm going to multiply the left side by, I'm going to multiply both sides by 14 and both sides by 6. So I could multiply both sides by 14. So like I'm going to get rid of this fraction. I'm going to multiply it by 14 over 1. If I do it on the left side, I have to do it on the other side, right? So those would cancel. So I'm also I want this fraction to go away. So I multiply the right side by 6 because that'll make those 6's cancel. So I have to do it to the left side. Right? So that's kind of where you get this idea of cross multiplying. That's why that works. It's basically cross multiply is like when I just kind of multiply this by this and this by this. It works out. Like the reason it works out is basically because you're multiplying by both denominators at the same time, and on one side they cancel. So if you end up with this, 6 times 8x plus 2 equals 14 times 4x minus 2. You might have been taught cross multiply, but the reason it works like that is because you're getting rid of the fractions by multiplying both sides by both denominators. And the ones that didn't show up, right? On the left side, look, 14 didn't show up. I multiplied it by 14, and it's what made it cancel. On the right side, I did multiply by 6 also, but 6 and 6 canceled. That's why 14 is only left. All right? So remember, since I have multiple x's, I have an x on the left, x on the right, I'm going to distribute to get rid of that variable, or that 6, those parentheses. So that's the distributive property. 6 is a pizza delivery guy. 6 goes to 8x's house and gives me 48x. 6 goes to 2, gives me 12. 14 is going to go to both. 14 times 4. It was 56, so I have 56x. And then 14 times negative 2 is minus 28. Now, I have x's on the left and x's on the right. You can move the x's all to the left. It doesn't matter to me. What I like to do is I pick the smaller of the two and I move that one. 48 smaller than 56, so I minus 48x from the left side, which means I have to minus it from the right side. Notice, I wrote the red negative 48x. I chose that. That's why it shows up on the right side. I chose it because it cancels. So I end up with 12 equals 56 minus 48 is 8x minus 28. Now I'm going to add 28 to both sides because, once again, I see subtraction, so I get rid of it by addition. So I add 28 to both sides. So then I end up with 28 and 12 is 40 equals 8x. How do I get rid of the 8? I divide by 8 on both sides. So x equals 5. Perfect. Good to go. All right. Now, if I want to check my work, I can. I'm just going to put 5 in right here and 5 in right here. So the left side would be 8 times 5, which is 40. 40 plus 2 is 42. 42 divided by 14 is 3. That's the left side. The right side, 4 times 5 is 20. 20 minus 2 is 18. 18 over 6 is 3. So it does work out if you plug it in. It is a good answer. All right, that's it. All right, last one. So there's a bunch of different things you can do. A lot of people hate fractions, so the first thing they do is multiply both sides by 2. Now remember, if you're going to do it, the right side you're distributing. So the first thing you could do is multiply both sides by 2. So the left side turns into 10x minus 36 minus, in parentheses, 2x plus 18. I'm actually going to distribute that at the same time too. So I'm just trying to I'm doing 2 steps at once. So I did 2 parts of distributive property. Now I have 2 times 6 is 12 minus 8x. Alright. Big mistake I see is somebody will multiply the top and the bottom by 2. The bottom and top can't, the new 2 cancels out with the bottom 2. That's why I don't affect it by the top. Alright, now I'm going to combine like terms. Minus 36 and minus 18 is minus 54. 10x minus 2x is 8x equals 12 minus 8x. Now I'm going to add 8x to both sides. So the reason I added 8x is because I picked this minus 8x because that's smaller than positive 8x. I want that to cancel. It doesn't cancel on this side. It ends up with 16x minus 54 equals 12. Now I got to get rid of subtraction, so I add 54 to both sides. So I end up with 16x equals 66. Now I'm going to divide both sides by 16x. Not 16x, I'm sorry. Just 16. I don't know. You can't divide a variable by a variable to make the variable go away, so it's just 16. So I end up with x equals 66 over 16. Right? That is not a simplified answer. If you're using one of like the Texas, you could simplify that by plugging the calculator with the ABC button. You can. Divide both sides by two, the top and the bottom by 2, because it could be also written as 33 over 8, or it could be written as 4 1/8, or maybe give me a decimal 4.125. All those are all of this, or this are acceptable answers. That would give you most credit. All right. That's pretty much a review of all your algebra and basics on solving equations. We started with one-step equations all the way up to multi-step equations, all the way up to multiple variables. And basic rule of thumb is learn this chart right here. Make sure you know it's only for one variable. And then it's kind of that simple. If you ever get lost, just writing that chart down will give you some partial credit right away. Shows me that you're doing work and you're making an attempt. Alrighty, that's it.